Hello everyone, here the question says, in terms of basic units that is mass, length, time and charge q, the dimension of magnetic permeability mu naught, magnetic permeability of vacuum. So to find this, the thing, whenever you see this magnetic, the word magnetic, you have to use Lorentz force to find it. Okay, what do you mean by Lorentz force? So let us consider, to understand the concept, let us consider a magnetic field. So this is a vector quantity, right? The magnetic field B. Okay, magnetic field B. Let us consider a charge q which is going to enter to this magnetic field in a perpendicular manner. We know that this is called a perpendicular manner with the velocity v. Okay, in a perpendicular manner with velocity v. So then the force attained by this charge q when it is enter into the magnetic field perpendicular to the magnetic field with the velocity v, so which is going to be directly proportional to, which is going to be which is going to be equal to, which is going to be equal to the charge q, the magnitude of charge q into b cross v. Understood? B cross v. Why it is in cross product? Because it is going to be entered in the perpendicular manner. So this velocity is going to be in perpendicular to the magnetic field. So that's why we are written in the terms of vector quantity. So when you convert it into the scalar, so you can able to get this q b v sine theta. Okay, sine theta. So theta is the angle between this velocity v and the magnetic field b. Okay, sine theta, the angle between this thing is theta. Okay, you must understand this is known as the velocity of the charge q v and the magnetic field to where the charge is going to enter into it. Okay, this is going to be the angle between these two is going to be theta, so sine theta. So this is force which is known as Lorentz force. So now we have understood the concept of Lorentz force. Now we are going to find the dimension for this b, so that we can able to find. So we know that b magnetic field which is going to be equal to mu naught. Okay, mu naught by 2 pi 2 pi current flowing in that conductor by distance between them. So we know this concept. We have to find this mu naught as per the question, so to find this mu naught, I'm just converting this equation. So this equation, the same equation which is given as b, so 2 pi a b by I, which is equal to mu naught. From this above equation, I'm just written this equation. I'm just moving 2 pi I a to the left hand side and I also to the left hand side. The remaining is going to be mu naught right here. So since to find the dimension of these things, I'm just moving to the next page. Okay, wait a minute. I've just changed the background. Okay, nothing is problem right here. So I'm going to find the dimension of this thing first of all. So I'm from this equation I'm just drawn the box here, right? So that is f by q v sine theta, which is equal to b. Okay, we have to find b, we have to find the dimension of b from here. So otherwise I am just substituting this value b in this equation. Okay, after substitution I will be getting 2 pi 2 pi into a. So instead of b I'm going to just substitute. You can able to see here 2 pi a, instead of b I'm going to just substitute f by qv sine theta, f by qv sine theta, F by Q V sine theta. So I, the current flowing in that conductor, so which is equal to mu naught. Okay, now we are going to find the dimension of this thing right now from here. So we know that these are constants, so it is dimensionless quantity, and the sine theta, so the angles are dimensionless quantity, they don't have dimension. Suddenly what happened to the mouse, I don't know. So this is also dimensionless quantity. So a is distance actually. Okay, I'm just saying a is distance. Force, instead of force, so dimension of force is mass into acceleration. Mass into acceleration dimension is t power l t power minus 2. So this is the dimension of force, okay, divided by the current. So current, the dimension is going to be in the ampere. Actually I'm just representing in ampere. So but the question asked here is the basic unit of mass, length, time and charge. So we have to find the current. So dimension, so instead of current I am just going to substitute something here. So instead of current, so this current, so we know that current is equal to the charge flowed in the cross section divided by time t. Okay, I'm just substituting this value right instead of the current I. So instead of I am just substituting this thing. Instead of I am substituting this value, which is q now in about t. So because 1 by I is present there, so instead of I am just substituting this thing right there. Okay, I'm just erasing this now. So continuing the dimension, so the upper, so time is added here, and charge is represented in q, so q square, so there is 2q. So velocity, the dimension for velocity is lt power minus 1, so which is equal to the dimension of mu naught. Right, by continuing this thing, so you can able to see here is this l get cancelled. Okay, t power minus 1 here, minus 1 will be present right here. So remaining minus 1, t power minus 1 will be present. This t power minus 1, this t will be get cancelled. The remaining thing is going to be m l, so by q square, so q power minus 2. Okay, when it goes up it becomes t. Okay, t squared into t, okay, right, which is equal to mu naught. The dimension of mu naught is ml q square. ml q square, that is option a is the correct answer for this question. ml q power minus 2. Okay, right, so you can just rewind it and understand the concept here.